Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome back to our ongoing chapter, that is the pressure. Today we are going to discuss the last thing of this chapter, that is the pressure of a gas and how we can measure that pressure. Before discussing that topic, I would like to just have a review of our previous uh, studies. That is, what do we mean by the gas pressure? This is actually the force per unit area that the particles in a gas exert on the walls of their container. Means जब गैस के particles move करते हैं किसी कंटेनर के अंदर तो वो walls के साथ टकराते हैं, force exert करते हैं वहां पे, जिसकी वजह से pressure create होता है. So that pressure is known as the gas pressure. So gases have few properties, that is the pressure, volume, temperature, and mass. What do these properties, how do these properties affect the pressure created by the gases? So the first thing, that is the mass. If a gas has more mass, means it will have the more particles in it. Hence, the more striking rate of the gas will be there and more pressure will be created. Means more mass, more pressure. Less mass, less pressure will be there of the gas. Second one, that is ये जो तीन factors हैं, the three factors, how do these affect of the gas? If the more mass is there, the first thing which we have discussed here, more mass means the more number of particles. So more collisions of the particles with the walls will be there and greater will be the pressure. You can say simply, if we double the particles, means if we double the mass, then pressure will be doubled. If we increase the mass of the gas 3 times, pressure will be 3 times. Is it? Second one is the temperature. If we increase the temperature of the gas, the molecules will start to move more vigorously and they will strike with the walls more frequently, hence creating a greater pressure. Here you can simply also say that higher the temperature of the gas, higher will be the pressure, and if lower the pressure temperature of the gas, lower will be the pressure. Then the third one, volume. If when the volume is not held constant, means the container in which the gas has been enclosed, it is not fixed, but it has a movable piston above it. Then if we increase the temperature, then the volume will increase because the gas particles will start to move further apart from one another. So volume will increase. And if we decrease the volume, the pressure of the gas increases. Means volume और pressure के दरमियान जो link है वो ये है कि if we decrease the volume, then lesser space will be there for the particles to move. So more striking will be there and high pressure will be created. So that's why the pressure is higher at lower altitudes and at the higher altitudes, the pressure is lower. Now, we have discussed a little bit how we can measure out the atmospheric pressure. That there was an instrument named barometer which was used to measure the atmospheric pressure. Atmosphere is actually a mixture of different gases, and atmospheric pressure is overall the whole pressure created by all of these gases, average pressure. So barometer, it is an instrument which measures the pressure exerted by the barometer. It only measures the atmospheric pressure, the barometer. Sometimes this pressure is also called barometric pressure, and this pressure is actually presented by the height of the mercury column in the glass tube of the barometer. Here is a picture of the barometer, a trough in which the mercury has been filled up, and a glass tube almost 1 meter long, which has been filled with the mercury and then inverted into the trough, and mercury falls a little bit and then stops here. This column of the mercury in the glass tube, this one from here till here up to the surface of the mercury in the trough, this mercury creates a pressure equals to the atmosphere. and the length of this mercury column is normally at sea level is 760 millimeters of mercury, or you can say 76 centimeters of mercury. So 1 atmospheric pressure is actually equals to the pressure created or exerted by the 760 millimeters of mercury. Atmospheric pressure can be expressed in two ways then, that is the 1 atm. It is the 1 atmospheric pressure which is which has been discussed, that it is equals to almost 1 lakh pascals, means 1 into 10 to power 5 pascals, and you can write it down as well as 760 millimeters of mercury. It will be at sea level. So there are two ways to present the atmospheric pressure here. And if we just have some other units of the pressure, we can say that the unit of measuring pressure is Pascal, SI unit, System International में. And Pascal is a smaller pressure unit. Sometimes kilopascals are also used, which means 1000 pascals. So 1 atm, it is equal to 760 millimeter of mercury, or it is 101.3 kilopascals. And sometimes it is also measured in pounds per square inches. Just like this one, 14.7 psi means pounds per square inches. This is a unit which is used when we are being there to have some pressure in the tires of our vehicles. So there the pressure is being measured in psi unit. Whenever you hear in a weather forecast that the meteorologists say that the barometer is falling, it means the level of the mercury in the glass tube is falling. And why is this so? Because the atmospheric pressure is lower, is going to lower down, is going to decreasing. Okay? So if the atmospheric pressure is lesser, then the length of the mercury column will be lesser. And if the atmospheric pressure is higher, then it will be longer than the usual. Is it? Okay. And then the last thing is there, how we can measure the pressure of an individual gas. Not of the atmospheric pressure, but the individual gas. The first thing, that is a piezometer. It is not in our syllabus, but just this is for your information, that it is a simple tube connected with a vessel in which some liquid is being held. And we can calculate the pressure of that liquid with the help of this piezometer, but it is not in our syllabus. So I am not going to explain it furthermore. This is just for your information. This is a figure of piezometer. The thing which is in our syllabus, that is a U-tube manometer, which is used usually to measure the pressure of both the liquids and gases. U-shaped glass tube, which is open from both the ends. One end is just under the pressure of atmosphere, and the other end is being connected to a vessel or a cylinder which contains the gas or liquid whose pressure we have to find out. That's it. And we can find out the pressure by the difference of these liquid columns in the manometer. This is actually the manometer, U-tube, U-shaped glass tube, and it is being connected to a container which is just filled with the fluid or the gas whose pressure we have to find out. So one property of liquid which we have learned in the previous lectures, that at the same depth in a liquid, the pressure is same. So the pressure at B and pressure at point C will be equal. Here we can say that the pressure here is due to the liquid or the gas which is enclosed in this container. So this pressure is equals to the pressure of atmosphere plus pressure of this liquid column. It can be written down as like this one. Pressure of the gas means pressure at point B is equals to atmospheric pressure plus pressure of the liquid column. Both of these two are going to equalize the pressure of the gas. So we can calculate the pressure of the gas by using this formula. Another case is there, second case, if the pressure of gas is lesser than the atmospheric pressure, then the level of this liquid column will rise in this limb and fall in this limb if the pressure of gas is lesser. Then we have to just use the formula, that is the atmospheric pressure minus pressure of the liquid column, means PA, pressure of the atmosphere, and minus rho GH. You can use the formula here, rho GH. If we have not been given out the density of the liquid here and the height of the column, density of the liquid is not being given, then we can even use another way to present the pressure. Means suppose if this height of the liquid column is 10 millimeters, then we can say that the pressure of gas is 10 millimeter of mercury higher than atmospheric pressure. We can say that the gas pressure is 10 millimeter of mercury higher than atmospheric pressure. So we can express the pressure in terms of millimeters of mercury as well, if the height is given and density is not given. Then we can present the pressure or calculate the pressure in this way. So that's all, students, for today. And in the upcoming lecture in the next week from Monday, we are going to start our next lecture, and that will be relating to the reflection of light. So up till then, take care of yourself. Thank you very much, and Allah Hafiz.